I'm Jeff Martin from Report Mill Software. We make Java developer tools. We've been doing it for 20 years now. We started in the Apple Web Objects world, but then we went full Java about 15 years ago, and we have a reporting tool that's basically a page layout program in Java and then an engine for generating reports. And so starting about 7 years ago, as a labor of love, I started writing a developer tool because we were teaching, my wife and I were teaching a class at our local middle school, and we just couldn't find the right tool that you know, a lot of classrooms are using Eclipse for this, and it's kind of, I'm stealing a line I think from Arun Gupta, but it's kind of like learning how to fly on a 747. So the idea of SnapCode was to be a lot more approachable to students, a lot simpler to work with. And then recently, in the last year, our focus has been getting those apps that you write in SnapCode to run in the browser. And of course, this used to be pretty easy 10, 20 years ago. But in the last few years, applets have, of course, fallen out of favor. So we've taken this approach of compiling the Java to JavaScript using a really cool library out there called TVM. So I'm going to give you a demo of kind of introductory programming concepts. And then showing how you can write them as desktop apps, and then with one line of code you can run them in the browser, and so that makes Java relevant again. That one thing our students, they would get excited by the programming, and they'd want to share it. They'd want to show mom and dad. They'd want to show grandma, and unfortunately at the time, wake that up. It was really locked inside of Eclipse, and grandma didn't have Eclipse running on her computer. So like I said, that's kind of the impetus for where we are now. So SnapCode is available at our website. It's an easy download. It's a nice self-contained IDE. So it's a 40 megabyte download, and it's got all the developer tools in there, everything to get you right to this welcome panel here and to start coding. And so I'll start by typing in, say I want a new project, and I'll call this Devo1, and open it up. And so I have a new empty project here. And so, so the first thing that we would do in our little class is use a tool like Scratch. And there's quite a few of them now. Google made one at one point, and there's a few online. But it's the basic puzzle piece programming thing. But our twist on it was that we made those puzzle pieces actually front for Java code. And so the thing we found out when we were doing our classes was we could teach them Scratch, and we could introduce them to concepts of method calls and functions, but then we'd kind of take a step backwards when we try to transition them to code, that they didn't quite understand, you know, how that mapped over. And so, so by doing this kind of Scratch environment on top of a real Java IDE, you'll see in a moment how we can just go back and forth. So I'll say I want to make a new Snap project out of this normal project. And so what this does is it adds our little SnapKit UI library, and it creates a new scene object, which is going to hold our characters for our little animation. And then I'll just say simply that I want to add a new actor, and I'll select the cat here and click OK. And so it's supposed to show up on the screen here, but we're kind of in the middle of a little re-architecture, so this feature is broken probably for another couple weeks. But in our scene, we see here that it actually added it added our cat class and a cat image, and then in our scene, in the constructor, it added a new cat. So for the cat, it's showing here the boilerplate code for a sprite in our little game But what I'm going to do is switch it over to SnapCode. And so this is where the Scratch-like environment comes into play. So we've got our constructor still and a main method and our act method. And so we can just do something really simple here, like say I want to drag in this move by 10. So this act method gets called once, 30 times a second, once for every frame in our animation. And so just with that one little guy in there, I'll click run. And so here's our program with the cat running off the screen. And so then I'll add a few more things in here. There's a pen. So in the constructor, I might tell it to, oops, that's not actually what I wanted to do. Here we go. So I'm going to tell it to do a pen down in the constructor. And then on each frame, I want it to change the pen color to random. And so I'll save this and run again. And so now the cat runs across the screen, and as he runs, his pen is leaving a mark, and on every frame it's changing the color. And then finally, to make it a full-fledged game, I'm going to say I want to set the rotation. So I have a rotation key here. And I'll drag that in. And I want to set it to, I want the parameter to actually be a method as well. I'm going to have it get the angle between the character and the mouse. And so just with those few drags there, we now have a cat chasing the mouse game. So this is a way of getting the students started doing programming, without all the problems of syntax and semicolons, and it can get them started almost as a game. But at every step along the way, they can toggle back and forth and see, oh, well, here's the code. This is actually real Java code that I'm creating. And so that way a stepping stone doesn't become a crutch that prevents them from moving on to the next level or slows down their movement to the next level. It's really just an assist that's introducing them to programming at the same time they're learning about, basic program constructs. So then one final thing I want to do here is what I was talking about earlier, is getting this in the browser. So after a day of programming, we want to be able to share it with the family. So what I'm going to do is I'm going to add another project, a dependent project to our little game here. And this is called SnapT. And this is what binds to the TVM compiler. I was mentioning it earlier, but it's a great tool written by this guy. It's remarkable. It deserves a lot more attention than it's getting. But it takes a compiled Java program and transpiles it into JavaScript. And so our whole environment, this SnapKit is really a UI library that is, it runs on top of Swing, and it runs on top of JavaFX, and there's an adapter to run in this TVM environment, which actually uses HTML's DOM. So it uses a canvas object, and it draws lines in HTML. So just by adding this project here, and then I'm going to add one line of code, that this is our main method, and the main method creates a view owner for this scene and tells it to set its window visible. But what I'm going to do right before that is I'm going to say SnapT TV set. And just by doing that, it's going to tell SnapCode to use the compiler that'll take us to TVM instead. All right. There it goes. So this is, it auto-detects that I've referenced SnapT or TVM, And so instead of running it as a desktop app, it generates the JavaScript, generates a little HTML stub file, and pops open the browser. And so here's that exact same game, just adding one line of code, and it's running in the browser. So that's kind of week 1 and 2 of a programming course. Then after a while, we want to get them comfortable with real coding. They're not going to be able to get a lot of jobs dragging around puzzle pieces. So I'm going to say I'm going to create a new project here, and I'm going to call this Devo2, and open it up. And I'm also going to add the SnapKit to this. And while I'm at it, I might as well add SnapT, because we're going to go to the browser as well. And I'm going to say add a new Java file. And I'm going to type in hello world. So our app here is going to be hello world. And so I want this to be a view owner. So SnapKit uses the most plain-spoken model view controller paradigm that we could possibly come up with. And so the view owner is the controller class. And so it basically has 3 methods in it: a create UI method, and a respond or reset UI method, and a respond UI method. So I'm just going to override the create UI method. And I'm just going to have it return a button that says hello world. And then I'll write my standard main method. And just like in the other one, I'm going to say new hello world for my view owner, set window visible to true. And so here we have our controller is our view owner, our hello world. Our view is what's created in this create UI. And of course, this can get as complicated or sophisticated as we want it to. And then our main method here. So I'll go ahead and run this. And this will run a very simple desktop application with our button in it, which is clickable. And then just to make it slightly more interesting, let's go ahead and make this a local variable and give it a size 300 by 300, and then return the button. And so now when we run it, we have it in a bigger window there. And then again, I can just say snapT.tv set. I double click, and because I've referenced snapT, it's running the compiler. And so here's that exact same desktop application running in a browser again. And so to show some of the other methods here, I've got a reset UI method that takes a view event. And up here, let me name my button, set name to my button. And I'll just say if the event is equal to my button, then the event get view dot set text to let's just say button was pressed. Let me run this as a desktop app first. Yeah, maybe I should be setting the, let's say, button.class. Well, let's see. Let me make sure this is getting called. No, it'll do that for us automatically. I'm sure I'm just doing something silly here. Yeah, of course. I'm using the reset method, and it's respond UI. I should have noticed I wasn't getting my override angle here, thing here. So now, yeah, I press it, and it says button was pressed. Yeah, so that's months 2 and 3 is teaching them about model view controller programming, and then of course modern programmers should really learn how to use a UI builder. So now I'm going to create a UI file, and SnapKit has a full UI builder and UI file format. And so this is what I did is I created a UI file that has the same name as our view owner class. And so when we run the program, it'll look for a UI file with the exact same name and automatically load it. And so I'll just drag in a label and a button and a slider, and I'll resize the slider, and I'll drag and drop in a logo here, and I'll save that, and then I'm going to get rid of our manual create UI method, and we'll just let it use the default, which will find our UI file. And so so now here's our program. And then once again, I will uncomment our JavaScript transpiler line of code, and it'll run the same program, but it'll compile it to JavaScript and generate our HTML. And in fact, let's reset the background of this guy to something. Yeah, so we wrote a desktop app with all those UI controls in it, and then with that one line of code, we get the exact same program running in the browser again. Yeah, so then let's see. Finally, I will another big one because I'm a dinosaur, I guess, is in our class. I felt like it was important to teach command line programming. That to me, when you're in a school setting, these kids are going to math class all the time, and they're learning, Pythagorean theorem, or they're learning how to, calculate the length of a alternate side of a triangle, and so those are some very simple formulas, and so I thought it was effective, and of course it was the way a lot of us learned. But to be able to take that knowledge and code it up very quickly, and one of the quickest, best ways to do that is just command line programming. So I'm going to call this one Devo3 and open this up. And so this is a new empty project. And I'll go ahead and add SnapKit again, and I'll go ahead and add a new Java file. And I'm going to call this scan test. And then I want this class to be a subclass of something we call scan pane. And then I'm going to write a very standard main method again. And I'll just start by saying system.out.println, enter 2 numbers. And I'll create a scanner. And so usually you create a scanner from some input source, a file or an input stream or system.in. I actually have one here that the scan pane has its own system.in that'll work from a UI or from system.in. So I'm going to say a new scanner from system.in, and then I'll say val1 is equal to scan next int, val2 is equal to scan next int, and then system, I want it in red, so I'm going to go with error. The total value is val1 plus val2. And so just running this as something you'd see in any Java book, right, this thing's on autopilot. Yeah, so here we go. So I run it, and just using standard system.in, it'll bring up the console here, and it's written enter two numbers, and I'll just say 22 and 33. Right, why didn't that work? Take two. All right, 22 and 33, and the total is 55. All right, so yeah, so this is the standard version. And then I want this to be a Java desktop app. And so a scan test is also a view owner. So I'll just say new scan test, set window visible to true. And so now instead of system.in, I will use the scan panes in. And so now we've got a desktop app. And so this is, I found it really annoying to teach command line programming, in the little console window, that they were more comfortable seeing a real application. So that was kind of the whole impetus of this scan pane, and then to get into the browser as well. Yeah, so here's the same program as a desktop app, and then I'll go back and add our TVM transpiler, and I'll add our magic line of code. And this is going to be anticlimactic because I grabbed a new version of the TVM compiler last week, and it fixed a couple of nice bugs. But for some reason, I lost system.out.println. But it is doing the scan pane part of it is working. But I'm going to have to do some debugging to find out what happened to my other one. Although actually, why don't we just go to the website? Yeah, so this is using an older version of SnapT, and so this one is about a 10-line version of that last program, where I can say add two numbers, 22 and 33 is 55, or I can say multiply 22 times 33, 726. And so this one, actually, it takes that scan pane and it wraps it up inside of a tab pane. And in the tab pane, we have a little source view.
So on the scan test, if you overran the vertical space, it would have the scroll bar and you'd be able to scroll through it?
Yeah. Let's see. I'm not sure I can. Oh, here we go. Yeah. Let's see what happens. I think it's inside of it. Yeah, there we go. Glad I've got a plant in the audience. I knew that would work. Yeah, so and there's a few fun ones there. So we even wrote a Greenfoot. Is anybody familiar with the Greenfoot developer environment? Yeah, so we wrote a Greenfoot emulation library that sits on top of SnapKit. And so once we had the Greenfoot emulation library working, we could take that to JavaScript. So let's see if I can find. Yeah, here's asteroids. So this is Greenfoot asteroids running in a browser. Yeah, so this is, all the Greenfoot, reset button, and let's see, I think there's even the feature that if you command click, it'll duplicate the object that you click on. And so now when we run it, we're going to have a much better chance of winning here. Yeah, so then there was there's BusyBox. So let me get really brave here. Oh, I don't have that source here. All right, so let me go ahead and run that one too. So this is just a lot of things in SnapKit, buttons, and so these are tied to our little animation library. And I can move through here, and there's even an animation for which thing you choose. And sliders have some animations on them.
That's in the browser?
Yeah. Yeah, so usually I keep a copy of busybox.java over here, and I just drag it in, and I run it, and it runs as a desktop app. And then I add the line, or uncomment the line of code out, and it runs in the browser. But I'm on my travel machine. I don't have that sitting here. Yeah, so that was a tool in action. and like I said, motivated by our experiences in trying to teach a little class. And SnapKit is free, and it's out there. It's I don't think a lot of people are using it, I think it's usually in a pretty good state. It's missing a few things right now that I ran into as I was showing you the demo. But anybody presses me on anything, we get those fixed. And that's my talk.